All right, guys, here it is. Last round. Here we go. So coming up in a couple of weeks, we're going to have a final exam for this course. And so if you read this comic, I use this on all my midterm and final exam reviews. So for some of you guys, this is like the fifth, sixth, seventh time you've seen this comic. So, I'm sorry I keep reusing it, but it's just I don't know, I think it's funny. All right. So, all right, but basically I want to kind of give you a heads up as to what you can expect from the exam. All right, coming up. All right, what is the exam format, and some review a little bit of the material, and then answer some questions. Okay, so the date of the exam is going to be Friday, June 25th. I think that's the last day of exams, actually. And so at 2:30, it'll be an MS form, just like the others have been, right? You'll have to join on MS Teams as well. So be here and be ready. All right. Now, I will make the exam just like the midterm. It'll be 100 points. I've experimented before with making it like, not 100, but something else, and it just really confused lots of students. So I've just 100 points, right? You can expect there will probably be a bonus again for taking the right version of the exam, that kind of thing. All right. It does represent 40% of your final grade. What topics will you be responsible for? Everything we've covered in this course. All right. So everything from the beginning of the semester to the midterm exam. Data structures, sets and maps, efficient algorithms, because we covered it last week. You will not be required to know sorting algorithm stuff, right? So you don't need to know how to do the calculation of the merge sort runtime, for example. Okay, the sorting was just kind of like getting you a little heads up to what to expect from a future course. But you will need to know some of that big O stuff, like what I talked about earlier today, about how to compare two big O runtimes. Again, I'm not going to give you an algorithm like Fibonacci recursive version and tell you to do the whole t of n equals t of n minus 1 plus t of n minus 2, and how to figure all that out to understand that it's 2 to the n. Not going to ask you to do that. I might give you like a simple set of code with like a simple loop in it and ask you to tell me what its general runtime is. But most likely I'll ask you to, if I like what the example I gave today in lecture, if I said big O of n squared log n, where does it go? What is it less than? What is it greater than? Or if I were to give you a list of 5 of them, could you put them in the correct order? That kind of thing. Okay. All right. And of course, topics from previous courses. Do not forget if statements just because we didn't do if statements this year. I hope you still remember how to do while and for loops. I hope you remember how to write methods. Okay, these are all important topics, the foundation of what we do. So if you don't understand those things, you're going to have a hard time with this exam as well. Okay. The format will be very similar to previous exams with some, the multiple choice, true, false, that kind of thing. We've talked before about matching. Can you tell me what the output of a method or the return value of a method? Really need you guys to know the difference between if something is printed to the screen versus if something is returned from a method. That seems to be still kind of a problem for a number of you, and that's really something that you should have learned and just kind of put it right here after CSE 101. Okay, there's a big difference. If I ask you what is the return value of a method, that means what gets returned from the method, right? I give it a value, I get a value back, right? Yeah. So also be able to tell me though in this one, in this time for 102 is we talked about exceptions. You need to know if an exception will occur and what exception occurs. Okay. All right. You may have to implement a system or a class or a method. This would just be writing code, understanding a UML diagram, essentially analyzing. I can't have you guys draw a UML diagram on a non-paper exam. So what we will do is, excuse me, I may, like in the midterm exam, give you a couple of UML diagrams and ask you some questions about it. Okay, I'm going to show an example of that today. We've done this example before. Hopefully you remember, why is it 11 and not 11.0? Well, because there's nothing but integers involved over here. Right? And order of operations is important, but mostly I'm just trying to show you what a multiple choice question looks like. Right? You guys know all these. Okay. Some of you guys still need to learn this about me. If I have always in a true/false question, it's false. Okay, I don't believe in always and never. Just don't believe in always and never. There are exceptions to rules, and we must be aware that there can be exceptions to rule, right? Method doesn't always have to return a value. A void method can be a method that doesn't return anything. Okay? Another thing that some of you still are not quite clear on in me is I don't even want to read this. You don't want to read this. It's true. Okay. If it's so long that you're just like, I get tired just from even seeing that many words on the screen, then it's true. Okay. Now, maybe for you, you get tired from seeing this many words on the screen. Okay. So it's not always whether or not you get tired from reading all the words. Okay, but it is if the amount of text goes beyond like 2 lines, if it's 3 lines, 4 lines worth of text, it's true. I'm not trying to trick you. Okay, I'm not trying to trick you into knowing, oh, is there a not somewhere in here? Is there one little word somewhere in here that's going to make this false? Not looking for that. Okay, so all right. Again, as always, as I don't like always and ever. Again, as generally is true, I like to use programming stuff to be able to get true/false questions, right? So if something is not true, it's false. Right? We talked about this before about the plus stuff. So this would be a false statement, because the value of I before does not equal the value of I after 2 ++ operations are performed. Okay. But what I might say here is, if the value of I before this statement were executed was 7, what is it now? And hopefully you would know, well, 7 + 1 is 8, 8 + 1 is 9, the I becomes 9, and this is false. Here, ++ I equals I ++. If I was 7 before, 8, 9. 9 is the value of I, but this is true because it would be asking the question, does 8 equal 8? Okay? All right. Matching. The way I did this in the midterm exam was I gave a series of multiple choice questions with all the answers of those multiple choice questions being the same set of 5 answers. Okay. Notice though, the same answer can get used more than once. Just because there might be 5 questions and 5 answers does not mean that it's automatic 1-to-1 correlation. Okay. Could be that an answer, if an E answer down here existed, it wouldn't get used, and that's okay. I can do that. Okay. What is the output? You need to be able to tell the value of the variable at various points, like be able to follow through. What is the output or return value? I should probably comment and make this a what is your output or return value? All right. You need to be able to follow through a if-else statement, set of loops, exceptions. All right. Make sure you understand that a finally executes even if an exception occurs. Right? If a finally block exists, it's going to execute even if an exception occurs in the try. Okay. Even if that exception is not processed. And I might give you a rather simple code segment and ask you what is the big O complexity of that code segment. Okay. As typically is the case in these exams, I may ask you to write a short program fragment, a short set of code, to be able to write a method, throw an exception, use a method of a parent class, use a set or a map or an array list or any kind of data structure. I might give you the same problem and ask you to complete that same problem using two different data structures. I might say, write this problem using a set. Now rewrite it, but use an array list this time. Okay, rewrite it, but use a hash map this time. Okay, there's lots of different ways to solve the same problem. Okay. Yeah, in fact, some of you asked me for an extension. Unfortunately, we are unable to give that because of when grades need to be turned in, but asked me for an extension for the last assignment because, oh, but we didn't have we didn't know how to use maps yet. Well, there's no requirement to use maps in assignment 4. I never put it in there. It could have made it easier for those of you who may have looked ahead or practiced maps on your own or had been through this course before, but there was absolutely no requirement to use a map. All right. And so there's lots of different ways to solve problems. Okay, so I may ask you to use a different type of use a different type of collection. Right, might give you a question that asks you, hey, we want to use a collection to be able to do these different things, right? And I want you to be able to tell me what's the best type of collection for this, right? Do you think an array list would work really well? Do you think an array would work really well? Do you think a hash map would work really well? Right, and so I may ask you a question like that where I'm saying this is the type of collection, these are the type of data items we want to keep track of. What type of collection should I use? And then also ask you to tell me why. Okay. All right. Again, developing a system, one of the hallmarks of being a good engineer is being able to take a problem, divide it into its smaller sub-problems, and be able to solve those smaller sub-problems, put the solutions together into an overall solution. Okay. We'll talk about this example, the bank example, in just a moment, and to help you understand some things here. Okay. Two things. One, special questions, and then two, final note, and then we'll do that bank example, and I'll open it up for questions if anybody has any. Okay, so some of you seem to not quite understand some aspects of the feedback feature on Microsoft Forms. Okay, I've gotten a number of messages during quizzes, right after you submit. Oh, I put this in there, but it says that this is the right answer. Oh, but I think I'm right, and you might be. Okay, there are lots of correct answers. Okay, especially if like what you did was simply, simply a typo. right? If you write the word the, but T-E-H instead of T-H-E, guess what? The form doesn't know that you just made a typo. It just knows you did not put in the answer that I gave it, right? But my feedback is not intended for you to know what the correct answer is. It's intended for you to have an idea in real time about what a correct answer was. And are you close? Are you on the right track? Okay, so during the exam, okay, until the exam is graded and returned to you, don't contact about feedback answers. Okay, but here's another thing I've noticed about that feedback stuff is I think because some of you think that that is the correct answer, you somehow get access to my feedback answers, and I've noticed that some people like paste them in like exactly like, yeah. So like in the quiz that was about assignment 2, I think, when I asked, no, not assignment 2. One of the quizzes where I asked, is it necessary to implement a certain method? And my feedback answer was no, and then parentheses I said, correct answers will, indicate that you understand this. Somebody wrote that as their answer, which really surprises me because I'm not really sure how they got that answer, right? But that was not the correct answer. That was me telling you, no, it's not necessary to implement it. And it was because the other method that it was using would be implemented in child classes because it was an abstract method. Right? And so what I'm going to do is I'm going to do like a little experiment, and we're going to see how this works. Okay? So I am going to have some feedback answers, not all, but some feedback answers will be intentionally wrong. Okay, and so if you put that wrong answer, you just expect that, yeah, your initial grading will show it to be correct, and you'll get, whatever points the question's worth. But then later, when I correct the feedback to be the correct answer, then you'll probably end up losing points over that. Okay. Another major thing that engineers have to know. Engineers have to know our limitations. We have to know what we can do and what we can't do. Right. And so one of the things that you need to know is you need to know what was the scope of this course? What was the intention of this course? Okay. And so at least one question I'm going to ask will be well outside the material from this course. We're not talking about like, oh, I'm going to ask you about a sorting algorithm. No. It's going to be something from way outside of the material of this course. Okay. And a blank answer is not what I need from you. What I need for you to tell me, we didn't cover this. We did not, we didn't do this in this course. And so if you put an answer, even if it's correct, I will say, no, you didn't understand that this wasn't part of this course. Okay. Again, this is somewhat of an experiment on my part, and we'll see how it works out. Yeah, I mean, part of what I've noticed is I've noticed that on a couple of exams now, on a couple of quizzes, I've noticed that some students seem to be finding some answers to topics out there that are from sources that aren't allowed. Okay? And so we need to make sure that you understand what it is that you're supposed to understand. All right. Okay. Again, I need you to write something in the blank that's like, hey, Hojam, this question shouldn't be on the exam. We didn't talk about this in this course. Okay. All right. So some final notes. As typical, okay, as I did for the midterm, you need a handwritten notes sheet that you will upload. The closed stuff, obviously, I can't do phone because Well, how are you going to take the exam without a phone or a computer or some other electrical device? So I guess you can't have, I guess you'll have to have one of those, all right, to be able to take this exam. Okay. And actually, I should have probably put this, I probably should have put a red line here on mouth too, just because, you know, if you want to scream in the comfort of your home and get angry and at the computer, you know, feel free as long as your microphone isn't on. Okay. I guess maybe closed microphone maybe would be the best way. Okay. All right. We'll do questions, but first I did say I wanted to do that. I did say I wanted to do that bank customer example. Let's see. Oh. I mean, Delara, I really, yeah, I'm gonna go ahead and say yes. It's necessary because I don't want you memorizing anything. I don't want you memorizing or yeah, that's not what engineering's about. Engineering's not about memorization. So I want you to prepare a note sheet so that you can prepare for this exam. Where are we? Go find my diagrams here. I can open existing. I think I did one of these before. Nope, wrong one. Did I put it in here? Maybe not. Is it in here? Well, can't find it. Guess I'll have to do a new one. Man, okay. Let's just do that. Sure. I'll delete it later. Okay, so let's delete these. All right, let's see here. I want my UML stuff. All right, where's my classes? There's my class. All right. So I said what we would do is we'd have a bank. And a bank maintains, let's call it accounts. For, let's call on customers. All right. And so I put a question like this on a recent quiz. Where are you? Yeah, I put a question like this on a recent quiz where we might say that a bank, you know, maintains accounts, and you could say, you can call this oh, come on. I want to change the word. I don't know why that's not working. All right, so we'll call that a bank maintains, right? And what we might say is that if an account exists, it must belong to a bank. Right? And do this kind of easy here. Now, if a bank exists, we might say that it can have 0 or many accounts, right? Now, if I were to ask you a question that would say, tell me what you understand about the maintains relationship. Okay. What I would hope you could tell me was not just, well, it's a one-to-many relationship. And I don't want you using words like, and participation is required on the bank side, on the account side, but not required on. What I want to know is, do you know what this means in real life? Okay, do you know what this means in real life? This means that a bank can maintain many accounts, but is not required to maintain any accounts. If an account exists, it must belong to one and exactly one bank. All right. What we might do is we might have a customer. Now, what we might do okay. Now a bank can have many customers. Now here, okay, how is this different? Well, a bank still doesn't have to have any customers, but if they do, they can have as many as they want. A customer, if they exist, must belong to a bank. Otherwise, why are we keeping track of them? Okay. And how many banks can they belong to? Many, right? So the way that we would say this is a customer must belong to at least one bank, but it can belong. They can have an account or be associated with as many banks as they want. Okay, a bank is not required to keep track of any customers. They don't have any customers, but they can have as many as they want. Probably one that would make a lot more sense here is, okay, so a customer can have accounts, and the way we might word this one is, okay, let me put this relationship here. Again, as before, a customer can have 0 or many accounts, sure. Right. And let's say an account can belong to 1 or 2 customers. Okay. Now that may sound a little bit weird. Again, this is one of those things that it's a design decision. Okay. This is something that I haven't seen a lot of in Turkey. It's what's called joint accounts or shared accounts. But I want my wife to be able to have access to money, right? And I need her to be able to buy stuff, right? And I don't want to have a second account for her to have her own account. And then I got to figure out, I got to put money in there. I don't want to deal with all that. I just want her to be able to have access to my account, right? So what we could do is we could say, okay, well, an account can belong to 1 customer or 2, you know, a single person or a married couple or whatever, all right? And a customer, if a customer exists, they're not required to hold any accounts, but if they do, they can have as many as they want. Okay. And what I'm trying to get across is that when you look at a system like this, so a UML diagram like this, do you understand what it means in real world requirements? Okay, like what, hopefully you understand some of the basic terminology of like, oh, well, bank to customer is a many-to-many relationship, right? But what does the one ... star mean in real life? What does that mean? What kind of restriction, what kind of requirement are we going to have to put on the system in order to make this happen? Same thing over here. What's the difference between this, an account belongs to one and only one customer, versus this, an account belongs to one or two customers? All right. That's not a simple change. That's not a super simple change. Right? Here on the diagram, it was easy. I changed one thing. I changed the number 1 to the number 2. Done. But in terms of how we need to implement that requirement into the system could make a big difference, because suddenly this relationship is no longer a one-to-many relationship. Now it is a many-to-many relationship. A many-to-many relationship with a specific requirement on one side of it. Okay. So when I ask a question of what do you understand about this relationship, I'm not just asking for it's 1 ... 1 on one side, it's 0 ... star on the other. Okay, that is not what I'm looking to see. Do you understand? I'm wanting to know, do you understand what this means in a real life system, and how different is it from this? All right. If we make simple changes in the diagram, how does it make maybe potentially big changes? What does it mean about our business rules? What are called business rules? Our requirements that we're putting in. Okay. Or what if I said, well, you know what, I just don't want this relationship here anymore at all. I'm just going to maintain, instead of a customer having a direct relationship with the bank, I'm just going to have them have a relationship with an account, and the account has a relationship with the bank. That's possible, right? And how is that different? Right. Okay. All right. So that's the bank, customer accounts, and then of course I would also want you to be able to tell me things like if I add this, where are you? Where are you? Come on. Oh, it's down here. All right. All right. What does this mean? Right. What does this symbol notation mean? Right? It doesn't mean that now suddenly an account has a personal, or an account has an investment. This is now types of accounts, right? A personal, right, is a type of account. An investment is a type of account. Right? Is a customer going to, are they required to have a personal account? No, not required. Are they required to have an investment account? No, not required. Right. They're not required to have any account, are they? But what we could do is maybe say, maybe we'll say it like this. Now, if we change our design a little bit, a customer is now required to have one or many accounts. Right? If a customer doesn't have an account, why are we keeping them in our system? Right. And so what this design decision tells us is that we are only going to keep track of customers that have accounts in our system. Now, do we know if the customer has a personal account or if they have an investment account? No, We don't know what type of account the customer has just based on this design. And that's okay. Remember, what we could do is we could have some type of data collection over here, a collection like an array list or a hash map or a set or whatever, where the customer's set of accounts is kept in that customer object. And then that set of accounts, it can be a mixed bag. It can be a mixture of personal and investment accounts. Right. All right. So when I'm asking, what do you understand about a certain relationship? I don't just want it to know, oh, it's 1.2 on one side and it's 1.star on the other. I want to know, do you understand what that means from a design perspective? What does that mean? What does that mean for the system that we are developing? Okay. All right. So that's how we do the UML stuff. So again, I could give you an example like this. I could give you a diagram and ask you, what do you know about the maintains relationship, right? I could also ask you, what do you know about what is it? What do you know about certain parameters? No, it's not certain parameters. Certain let's put it this way. What I'm saying is, here for customer and account, what we would need to do in order to keep track of these is that an account would either have to have a set of customers that it belongs to. So every account would either need to have a customer object or two customer objects, right, inside of it that tell us who its customers are, or the customer class, the customer object, would have to have some type of list holding all the accounts that a customer owns. Right? Either one of those is acceptable. They can do it either way, right? So what I might ask is, how would you choose to implement this? Because those are the types of things, they wouldn't show up on the UML diagram. The types of things like are in field type and attribute types, things like name, phone number, email address, over here, account number, account balance, things like that, right? We don't have to keep a customer object in here. We don't have to keep a customer in here, but it might show up when we actually implement this thing in Java code. Right? And we talked about that this semester. We talked about that, about how just because the field doesn't show up here doesn't mean that it wouldn't be something we would need to put into the implementation when we actually write the code. All right. Another thing that I noticed on the midterm exam, a lot of you noted that there weren't get and set methods. Usually for get and set method, unless it's an extremely complex method that requires like lots of stuff, I can't remember them seeing them included in UML diagrams, because they're so simple and they're basically the way that we access those. Yeah, because they're just the simple, assign a variable, return a variable type methods, and because any attribute, any field that we would want, we would know we would need a get and a set method for it. So we don't normally take up space on the UML diagram to include all of our get and set methods. Okay. All right. So that's what I have for today for that, for final review. Are there any other additional questions that you guys would like to ask? Before we end for the semester? Last chance. Okay. All right. Well, thank you guys for attending, and thank you for dealing with a difficult semester, a difficult online learning experience. Yeah, I hope that next semester we will be back to face and things can kind of sort of go back to normal. All right. Other than that, I will see you in 2 weeks for the final exam. And until then, I hope you do well on the rest of your exams and enjoy as much as you can this coming weekend before finals begin. Have a good afternoon.